Hi, I'm Jeff Reed, co-founder of Grizzly Systems, and I'm going to give you a brief overview of what the company has been up to in the smart camera trap area. These things right here, which you often find outdoors. I'll briefly cover the problem we're solving for and then give a demo of our software platform. Our co-founder, Cody Goldhahn, has put together a separate video where he covers details about the hardware platform and our smart trigger technology. So the battery-operated camera trap technology is often used in hunting, wildlife research, and security sectors. They've basically tried to mimic the cellular phone industry in terms of features. You make the camera better. In other words, you make the images better for the cameras. You make the connectivity better, and you try to maintain long battery life. The camera trap market's a pretty small market. $80 million a year is the projection by 2026. But the TAM for the video surveillance market is going to be about $100 billion by 2028 with a 10% CAGR. The global smart home security market, which is a subsection of that, was valued at about $6.4 billion in 2021, and it's expected to expand at a compound annual growth rate of 18% into 2030. We believe our smart trigger technology applies to all of these markets. Grizzly Systems is a Montana-based tech company that specializes in scalable hardware solutions and advanced data processing. We design and deliver reliable, automated, remote sensing systems that provide our users with greater situational awareness of their assets. Cody and I have been working on security and game trail cameras for public companies and private nonprofits for a while now, whether it be in Manhattan to reduce crime by finding suspicious activity in thousands of live video feeds with petabytes of data, or monitoring for wildlife conservation here in Montana and Kenya. In the top left, you see a picture of one of our early prototypes. It was used to monitor grizzly bear and livestock conflict areas here in southwest Montana. Cody built a system in Kenya to monitor for poaching as well as species biodiversity, and here below in the bottom left to incentivize wildlife coexistence strategies with ranching operations. Monitoring wildlife for conservation purposes is often a very manual, data-intensive process. It's not cheap to do well, but when done well, it can have huge benefits. And it's not the only reason we built this smart camera, but it's one of our passions. The key problem with the existing technology is that they take a lot of photos of things you don't care about, like this one. Here's a popular game trail camera, which takes a video of grass and trees moving in the wind. While the game trail camera market is mostly unsophisticated technology, piggybacking on other industries like cell phones, the home security camera market are run by the best of the best in tech, like Google and Amazon. But here's some homework for you. Take one of these Google Nest outdoor cameras, which can operate on batteries, and they basically claim you can take 9 to 12 videos a day and still get 3 months of battery life. Take one of these and stick it out in your backyard. Turn the motion detection feature on. What you're going to find out is fairly quickly your phone's going to light up with a bunch of false positive alerts. But if you turn off motion detection and turn on its people detector, car detector, or pet detector, you're going to find that it works pretty well. We're solving for the former problem and leveraging all of the great things about object detection that you can run in the cloud. In other words, we're getting rid of grass blowing in the wind. So if you want to build what we call the no grass camera trap, this is the scale of the problem you're facing. So this is the amount of biomass weight of plants in the world compared to animals down there in the bottom in the gray. And humans are a subset of animals, so that's even a smaller subset. So if you got this much plant matter in the world, of course you're going to get a lot of false positives based on motion. You're trying to tell a pretty dumb device to find what matters to you. You're trying to find a needle in the haystack. And of course, if you're being charged for cellular connectivity to transfer those pictures, or you want your battery life to last a long time, it's going to cost you more money to find that needle in the haystack because of all of those false positives. And it's not just grass blowing in the wind that causes these sorts of problems. Here's another game trail camera taking a false positive video of sunlight and reflections. This is not a needle in the haystack, it's the haystack. Here's another false positive, snow. Turn motion detection on your Google Nest Cam, and if you live in a snowy place like me, you're going to find that they totally disregarded this in their cameras. This is the needle in the haystack you're looking for. We call her Mama White Claw. She's been raising a couple cubs, these two, for the last couple of years on our property here in Montana. If you have to go through 99 videos or images to get to this one, you've wasted a lot of time, storage, power, and bandwidth, or money. So here's the approach we've taken at Grizzly Systems to build our no-grass camera traps. We have both low and high power solutions, in other words, battery operated or plug-in solutions, and we have connected and unconnected solutions. So basically, you're taking a bunch of images, like a car that came by or a boat flowing down the river or animals or livestock, and you don't want grass blowing in the wind. And grass, snow reflectance account for over 95% of the false positives in any currently developed power or battery operated edge cameras. So we built our hardware platform and we focused on what we call the ultra low power PIR AI trigger, our smart trigger. And its job is to get rid of all of those false positives, grab image, video, and audio of things that are alive. So people, animals, or accessories to people like vehicles. Then we throw in different telemetry like location, temperature, all the sorts of sensors you can pack into these devices. And we push them up to our SaaS-based IoT management platform where we can manage these devices at scale. We can do user and device management. We can push firmware updates over the air. We have a rules engine that you can use to trigger, maybe send an email or an SMS or integrate into Slack. We have a storage platform, API integration, and an analytics UI engine. We have an unconnected version where you can do data offload from an unconnected camera and push those into our cloud platform. And then, of course, we have connected platforms where we use cellular, satellite, or Wi-Fi. And then we have a proprietary mesh platform where you can take one mama cam, we call it, and a bunch of baby cams and stick them out there. They mesh together, and then the mama cam is connected off to our platform. So you're starting to see more and more AI on the edge and in the cloud where you do species, individual, or threat detections on a classifier, on a GPU that's on the device. That's one way to do it, but it consumes power and it costs more to do it that way. So we have a solution for that if you want to do really specific AI classification on the edge. But for most use cases, we've basically taken that classification engine, pushed it off into the cloud in our cloud platform, where the cloud and massive compute can get really, really good at doing what it does, which is object detection. On top of that, we have a bunch of ecosystem partners. So for example, if you wanted to have a do-it-yourself AI where you developed something to detect cougars or to detect boats on a river, you can build that classifier yourself, plug it into our system, and those images will get post-processed and the AI will happen to it after it gets to the cloud. We also have third-party classifiers from experts who might be really good at wolverines or North American species like synthetic. These sorts of AI classification engines are really good at doing what they do. So here's an image on the same property I showed you before from a classifier called Mega Detector that came out of Microsoft. And you can see it detected a vehicle, 2 people, and a dog. Instead of running that massive classifier on an edge camera, which would consume a lot of battery life, we run it in the cloud. We've already gotten rid of the grass blowing in the wind scenario, and now we let the cloud do what it does really, really well. On top of that, we have ecosystem partners where wildlife managers use platforms from companies like Vulcan or Esri to manage large landscapes. But even like the consumer might want to plug into something like Slack or Teams. And if this photo is detected, you might want to kick off a Microsoft Teams conference. Everybody looks at the image and then they decide to do, what to do with it. So, you could call the warden and dispatch someone to go look at a security situation. So we're really focused on this smart trigger, and this smart trigger can be put into all sorts of scenarios, like this really, really good wildlife camera. So you attach our smart trigger to it. It does what it does really well, which is get rid of false positives, and the camera does what it's really good at, which is take very high res video for maybe a media production. So I'm going to give you a demo of our IoT SaaS platform where you can manage and look at these images. And like I mentioned, Cody has a separate video where he gets into the details of the hardware. You can obviously push the fast button on your video replay and speed this demo up if you want to. So here's the home screen on the Grizzly System software. So I'm just sitting at my desk and here's 2 cameras that are out, and I can get a sense by looking at them for this time scale that the one up on top has taken a lot more pictures and events have happened at that than the one down below. On the right, I can scroll through pictures. Here's a trespasser, a sneaky little guy. I can go in and just focus in on one particular area. So I'm just looking at this camera now. I might want to change the time scale. I can go over here, scroll through the pictures till I see something I want, click on it, download the whole image, and do whatever I want with it. You can go pick a camera or a group of cameras and visualize them like that. Another visualization is simply looking at all of the images on a particular camera. So here you see thumbnails, links to the thumbnails, the camera that it was taken on, which you can select up here. And then we have this notion of an event. An event is when our camera triggers, right? Our special secret sauce triggers. An event then might take multiple sequences of pictures and a video, and that's part of one event. So you see these sequence numbers here are telling you that this is photo 6 of that event. You can hover over it and see both the picture and then our thermal AI technology, which shows you what triggered the camera, right? So you might be interested to know what was really picked up in this particular picture. What triggered it? You can scroll down through all of the images. here we have some elk, and you can see the thermal camera and the body heat of that elk that triggered the camera. You might look at a picture too and go, wait, there's nothing in the picture. But the thermal imagery detected something, obviously. And in this particular case, we drove the truck by so fast that the camera couldn't trigger. But we got the photo. I mean, we got the thermal imagery to prove it. In this particular case, at night, you don't see anything in the photo, and even if you download it, you wouldn't see anything. But up there in the top left, you see what triggered the camera. And I actually don't know what did this, but for all I know, it could have been an owl that was just flying by in that top left corner. And of course, you can see the photo location. So here's the total amount of events for that camera on this time frame. Again, you can change the time frame. Now I'm down to 22 events. And then how many images were taken for all of those events. You might also just want to wake up and go, how many events happened? Because all I really want to know is how many times did the camera think something was there? And so now I'm only looking at 37 events, and I'm going through them and I'm seeing, okay, this is of interest to me. Then I might go back and look at all the images for that particular event ID. Then you can do some really interesting analytics. Suppose I want to see all of the events over a particular time frame, and because each photo is time-stamped, you can see the concentration of those events. So right here, you're seeing a bunch of activity at this particular camera. I can go in, pick a particular event and see what that image was. And then there was another event and so on. You also might want to see events by hour. Instead of the actual time of the photo, you might want to group them together in an hour of day to see at time scales of hour how much activity is going on. So over here, you see that on this particular day, May 24th at 2 p.m., there were 5 different events. And then I can go over here, scroll through the photos, and download those I want. So it's a different way of looking at events over time scales, but also trying to see what time of the day might be certain activity happening. I can do the same thing with the day. So I just want to see for a day how many events happened. And here, for example, on May 26th, there were 12 events on this particular camera and 2 on this one. And then I can go over, scroll through the images and pick out the ones I want. So I can see when there's a lot of activity. I also might want to do things like aggregate all of those images and then look at them just by hour of day. So these are all of the images that were taken at, for example, noon, from noon to 1 p.m. So I can get a sense for when is my activity happening. With wildlife, it might be happening at dawn and dusk, a lot more. With human activity, it might be during working hours, and so on. And now that we have all these images up here, we can run them through any sort of AI model. In this particular case, we're using a detector called Mega Detector, and it goes through the images and then runs its classifier in the cloud at very high accuracies and tells me what's in the particular photo. So it classifies it. In this particular case, it's a vehicle, and you can see it classified it. And then you can go in and pick things like pick a particular model version. So you might have 10 different models. One might be really good at detecting elk. One might be really good at humans. Certain types of vehicles. that you want to look for, and so on and so forth. And you might want to only see certain types of classifications. So in this particular case, classifier 1 is humans. And so we're getting images, events. There were 18 events within this time frame where humans were detected in all of the images. So that's a quick overview of the user interface and how it can be used. This is our camera management portal, where you can manage devices at scale. You can push firmware updates to them. You can create rules. You can do complicated analytics across timeframes at scale with massive IoT data streaming in. And as you can see here, I'm logged on, and as this particular user, I can see these two cameras. And I can go into a particular camera and see real-time telemetry data coming in on the camera. So that telemetry data has our proprietary information in it that allows us to track the images and different types of telemetry on that camera. So it could be audio, you could be recording audio, which allows you to reach farther than the vision camera actually does. Like I mentioned, we're already doing thermal and RGB as well. You can group cameras together. There's a data explorer, so you can search through all different types of cameras and run different reports and save those for yourselves. You might be interested in certain types of species coming at certain times a day. It basically lets you do your own reporting off the data that's unique to your use case. There are dashboards you can build to visualize different things, like what's the battery life on the camera. You can look at images on there. You can see how many images the camera's taken to date. You can export data and save it someplace else for usage. And then you can create all sorts of different rules. So this is where you can plug in your own detectors. So you might have an AI model running on AWS or Google or something, and you can plug those in, and as an image comes in, run it through that detector, classify it, and save that data to our database so then it shows up in your user interface. You might want an image to get emailed to you or sent to a Slack channel or a Microsoft Teams channel or anything. You can create all sorts of rules here in our management portal. And like I mentioned, here's the data export capabilities. So you can export and use the data for whatever you want. I want to give a quick plug to some of our partners and customers who have been using this system for various conservation and security use cases. Thanks a bunch for listening, and here's our contact information if you want to reach out and learn more about Grizzly Systems.